Today we are going to do 8M7, lesson 7, infinite decimals. Okay, so we're going to quickly pop over to our draw pad and get on with today's lesson. So yesterday, or in lesson 6, you learned how to detect two things: how to detect whether a fraction would terminate or repeat forever when written as a decimal. So we looked at fractions like this, and we could detect which ones of these would terminate and which ones would not terminate. And it was based on the denominator. There were some keys to the denominator, and I'm not going to go into those now. Hopefully, if you need to ask those questions about knowing whether these terminate or not, you could go back to lesson 6 and find out. The second thing that we learned about is how to convert fractions that would terminate into decimals without using long division. So for example, I know that this fraction will terminate due to rules that we learned in lesson 6, and I learned how to convert that into a decimal representation without doing any long division. The typical method is to do this, but the method that I showed yesterday in lesson 6 was how to do this transformation using different technique. Ooh. All right. Hopefully you remember how to do that, or I expect that you remember how to do that. In today's lesson, though, we're going to learn how to represent decimals, including infinite ones, on a number line. So that's what your homework. This is 90% of your homework is going to be doing that kind of stuff. And the second cool thing is we're going to learn why 0.9 is equal to 1, or at least a good argument. We're gonna see a good argument. Why? And it's based on this trick, or this ability that this skill that we're going to develop today, that helps us represent decimals, including infinite ones, on a number line, or at least to approximate them. So let's get on with the lesson, and we're going to start with some basics, and these are basics that you've learned in past years. So the first thing we're going to do is we're going to learn how to write this fraction using powers of 10. But before we even do that, let's go back to a basic building block that we learned in, I think, 6th or 7th, I think it was 6th grade, where we learned how to write 149 and other decimals, or other whole numbers, using powers of 10. And what we learned was that in our system of writing numbers, that there's something special about each digit as we go to the left of the decimal point. And that is that each one is an additional power of 10. So what do I mean by that? Well, this is our ones digit, which is also 10 to the 0. So remember, when we learned this before, 10 to the 0 is 1. So when we think of our ones digit, that's 10 to the 0 power. So this is 9. This means 9 ones, or 9 times 10 to the 0. This one is our tens digit, or our 10 to the 1st. So this means 4 times 10 to the 1st. And similarly, this is our hundredths digit, which is 10 squared. So we could say hundreds, we could say that's tens. And so this is 1 times 10 squared. So when you write 149, you can write 149 as equal to 1 times 10 squared plus 4 times 10 to the 1st plus 9 times 10 to the 0 power. And we have an exact same situation going on when we write numbers like this number here. So let's look at this, 0.6789. So this is our 10th digit. This is our 100th digit. This is our 1000th digit. And this is our 10,000th digit. For those of you who remember our negative exponents, this is the same thing as 10 to the negative 1. This is 10 to the 100, 1 over 100th is equal to 10 to the negative 2. 1 over 1,000 is 10 to the negative 3, and so on. So we get this nice mirror. So we have numbers like, 394.16, and this is 3 times 10 squared plus 9 times 10 to the first plus 4 times 10 to the 0 plus, and now this is our 10 to the negative 1, so plus 1 times 10 to the negative first plus 6 times 10 to the negative 2. Okay, let's keep going. I'll go back to my pink for a second. So let's just stick here and we're going to focus on this level. We're not going to use this 10 to the negative first representation, although we could. We're going to use this representation today because that's what the Eureka Math people wanted to use. So we'll use that representation. So we get this number, 0.6789 is equal to 6 times 10 to the 6 times 1/10. But we're not going to write it like this because 6 times, well, let's write it like that. And then we're going to change it a little bit. Plus 7 times 1 over 100, 7 hundredths. And how many thousandths? 8. So we get 8 thousandths, 8 times 1,000, plus 9 times 1 over 10,000. And we can write that 6 times a tenth, we can write that as 6 over 10, right? Let's show you that, because 6 times 1/10 is equal to 6 over 1 times 1/10. So that's equal to 6 over 10. So we can just take that 6 and multiply it on up. So 7 times 100th is 7 over 100 plus 8 over 1,000 plus 9 over 10,000. So that's 0.6789. Okay, so just to make sure we understand, let's answer this question to make sure we understand this. Which is greater, this number, 0.6789 or 0.678? Which one's greater? Well, let's look at it. Well, this one we know. We just wrote that one. That's 6 over 10 plus 7 over 100 plus 8 over 1,000 plus 9 over 10,000. And this one we can write and say, well, that's 6 over 10 plus 7 over 100 plus 8 over 1,000. So now you should hopefully be able to see which is greater, this one on the left or this one on the right. Well, let's see if we put those things on a balance. You put those on a balance and see which one's heavier. Well, this is the same. These are the same. These are the same. And now we have this is left over. So this left side is bigger by 9 over 10,000. So 0.6789 is greater than 0.678. Okay. So This is pretty relatively straightforward. So the whole key to this building block here is knowing how to convert decimals into these, into these fractional representations. That's what we learned on this slide. So let's go ahead and use that, and we're going to learn how to put numbers now onto number lines. So we're going to learn to write 0.375 using powers of 10, and then find it on the number line. Whoops, we somehow we lost some of our words here. We're going to find it on the number line. Find it on the number line. And to do that, let me just move this down a little bit. So let's use our strategy. 0.375. So we know that that's, 3 over 10 plus 7 over 100 plus 5 over 1,000. Okay, so that's a number that's between 0 and 1. So let's write that on our number line here. This is our first number line. So this goes from 0 to 1. And now we know that this number here is less than, by using the strategy that we learned before, it's between 0.3 is less than 0.375, which is less than 0.4. And we can use that same strategy on the last page to see that this is true, that 0.3 is less than 0. This number here is bigger than 0.3, but we can also use that same strategy to see that it's less than 0.4. So we know then, let's look at this, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So we know that this number is between here in here. So between 0.3 and 0.4. 0.6, and then we can keep going, 0.7, 0.8, 0.9, and then 1.0, and this is 0. So it's between here and here. Now what we're going to do is we're going to blow up this number line like this. Watch what we did. We're going to pretend that this, now we're going to say that this is the part of the number line where this is a 0.3. We just magnified this little section in here. And so over here we get 0.4. And we'll say 0.40 and just is 0.30. So this here is 0.31, 0.32, 0.33, 0.34, 0.35, 0.36, 0.37. We're going to be doing this over and over. This is the whole strategy for today. And this is 0.39. So where does 3/10 0.37? 0.375. Where does it fit? Well, it's between 0.37 and 0.38. Right? And we can use that same trick that we learned on the last page. Right? This is 3 over 10 plus 7 over 100 is less than, and this is 0.37 is less than 3 over 10 plus 7 over 100 plus 5 over 1,000, which is this number, which is less than 3 over 10 plus 8 over 100. Okay, so we're in between 0.37, so we're in this range right here. So this over here becomes 0.37, and over here comes 0.38. And so we're going to blow up this little part we're going to blow up this little part of the number line into these buckets. And so this becomes 0.371. This is 0.372, 0.373, 0.374, and this is 0.375. And so we have an exact match. So here's exactly where 0.375 is, 0.375 is exactly at this spot, which is halfway in between here, which is kind of off to the right side of here, if we blow this one up. So it's kind of right about there. Right? It's in the middle of this one here, but this one's off to the right, kind of off to the right side of this section. We're over on this side, so right about there. Okay, so that's how we're going to do this. We can do a similar thing. Let's try this one. This will be shorter, but let's do this one. We'll do this one in green. So here, let's try like 0.82. So here we go between 0 and 1. And this over here is, and I'm going to do this one shorthand. I know it's between 0.8 and 0.9. So we're in this little section, right? 0.8 is less than 0.8, which is less than 0.9. And I can put these zeros on here to make it really clear. This is 0.80, 0.82, and 0.90. So it's very clear that we're on this bar here. So now if I say over here, this is 0.80, and this is my 0.9, which is 0.90. This becomes 0.81, 0.82, and there we have it. We're right here, 0.82. And I don't need to use any more bars on down the road, because this is kind of like, this is my tenths. This is my 0 to 1 broken down by tenths, and this is broken down by hundredths. So now we're over here kind of on the left side of this guy. So we're right about here. And let's just make that dot, we'll put it in purple. We'll put it in purple, I said, purple. It's right about here. Okay, so we're just using number lines, taking the section, we're identifying where in what tenth, what little piece of a number line is a number is located on, and then we're blowing it up. So we're taking this little section and we're magnifying it 10 times, and then we're going to look at a more exact location for that number. Okay, let's try some more. Let's try some more numbers here real quick. And so now we're going to move into a world where we're going to deal with infinite decimals. So now we can't find an exact spot on a number line for infinite decimals, and you'll see why here in a second. But we're instead just going to approximate using our tools, using the tool that we just used. So this is, you're gonna have to write this out a little bit to figure out where to put it. So let's do that. So that's 0.18, 18, 18, dot, dot, dot. So now the first thing is to figure out, where does it fit on this line? Well, this is between, it's between, let me just write it out here, 0.1818. Well, we know it's between 0.1 and 0.2. All right, because of this decimal here. This number is bigger than 0.10 and less than 0.20. So let's put that down. This is our 0.1, and this is our 0.2. So we know that it's in this section right here. So now over here, I put my 0.1, and over here, I put my 0.2. And I can put my extra 0 off the back because that sometimes really helps me out when I'm writing this next set of numbers. So now I go, this would be 0.11, 0.12, 0.13, just making sense, 0.14, 0.15, 0.16, 0.17. If you know how to do this now, maybe you can go do that one on the right, 0.19. So now we have to go one more digit. So what is between 0.18, 18, dot, dot, dot? Well, that's between 0.18, because we're looking at this digit. So we just kind of, it's almost like we just copy this. Now we copy this extra digit down, and then we go one more over here. So it's in between 0.18 and 0.19 because we have to find which bar is this between. So over here, we're going to do 0.18, and I'll put an extra 0 there, and 0.190. Now I got to figure out which is 0.1818, and now I need one more digit. So we go 1.81 and 1.82. So this is our 0.181, and this is our 0.182. So we're on this bracket here. So now we need to do one more, 0.181. So this is like, kind of one extra digit. This is 2 extra digits, and then this is 3 extra digits, and this will be 4. So I'm just kind of looking ahead. 1, 8, 2. Let's put down our extra 0. And so now we got 0.1818 is between 0.1818 and 0.1819. So that's going to be, we got to look at that last digit. So this is 0.1811. So this is 1811, 12, 13, 14, 15, 16, 17, 18. So this is 0.1818, and this is 0.1819, and we're between those two. Okay, so this down here has got to be 0.1818, and over here it's 1.1819. And our number again, now we need one more digit, 0.18181. So that's here. 0.18181. 18181, and this is 0.18182. So here's our best estimate. We're in this range. We're between 0.18181 and 0.181. Wait, 1.1818. Okay. So, right, 1.182. And so that's the closest estimate that we're going to get. And that's a pretty good estimate. I mean, and we've kind of graphed it down on this number line. So we're off kind of to the right of this guy here. So you're just going to do these kinds of approximations. And it really, you could have written this without doing these number lines, but it's the exercise that we're doing here in lesson 7, and they're going to ask you to do it on the homework. So here we can do the same thing. We know that, let's just write this out. We can kind of even do it shorthand. Let's just see if we can do this. So we're going to write it like this. And then with dot, 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 that's our number. So we know on the first one, we go between 0 and 1. And then we got to figure out, what do we have to do on the second one? Well, we're going to go between 0.4 and 0.5. And I'm just doing a shorthand of what I did over here on the left. So I know this number is between 0.4 and 0.5. So I can draw it out like this, and I can say, well, that's 0.4, and that's 0.5. And now I got to go to the next one. So this is between 0.45. So this is 0.41, 42, 43, 44, and 45. So this is 0.45 and 0.46. Right? Because this one's 0.4. And then 5 is the next number that I'm looking between. And so I'm looking between, because I know that this is between, right, 0.44, so sorry, 0.4 and 0.5 because of this digit. Now on this next one, I know that we're 0.45. And so that's between and then it's 0.456. So I know we're between 0.45 and 0.46. On this next one, so now I go 0.45 here, and here I'm looking at 0.46. So now I need 0.4564. Okay. So we need to go out to the 0.456. This is 0.451, 52, 53, 54, 55, 56. So this is 0.456, and this is 0.457. So this is 0.456, 0.457. Now I need 0.45645. So now we got to go back to 0.1. This is 0.4561, 62, 63, 64. 0.456. 0.4564. Sorry. 5. Zero 0.4564 and 0.455. Okay, and so this is 0.45641, 42, 43, 44, 45. 0. And that's this one. 4, 5, 6, 4, 5, and this is 0.45645. Sorry, 4, 6. We're in this bar right here. And so that's in here is 0.45645. That's 40. That's 50. Okay, so this is I don't know how useful this is. It's a good visual exercise to see how to approximate numbers down on a number line. And then we're going to use this really quick to show you one final piece. So this is what your homework is going to do. And you're just going to use this and you're going to draw pictures to estimate numbers on number lines that keep getting blown up. Okay, so the final piece here is we're going to try and do this little proof by approximating 0.99 on a number line. Okay, and then we're going to try to find out, is there any gap? This is the question you're going to be thinking about. Is there any gap between 0.9 bar and 1.0 on a number line? If the answer is there's no gap between them, then they have to be the same number because they're pushed right up against each other, right? So the idea is on a number line, if we have 0 here and 1 here, if 0.9 is right up against the 1 and there's no gap, and we can show that there's no gap between them, then effectively they're the same number. And that's what a mathematician would argue. Maybe in 8th grade and 9th grade, we look at it and we say, well, you know, they're different because this is just a little bit less than 1. But mathematician's going to say, well, if there's no gap between something, if I have my 2 fingers pinched together and there's no gap between them, then they're basically in the, you know, they're touching. They're the same thing. So let's look at this. So we know that 0.99 is between, so this is 0.99999 ... So we know that that's between, using the prior argument, is between 0.9 and this 1.0. So we're in this bar here. So I can take this down here and say, well, this is 0.9 and this is 1.0 and this here is 0.99 and this is 1.0. All right, so here we're looking at 0.999. Here we look at 0.9999. We'll be looking at this one. This one will look at 0.9999999. And finally, we'll look at 0.99999. And we'll see if we can draw, because here we're looking at 0.99. Where is it? You know, where is it on this line? Okay. So now we have 0.90 and 1.00. Well, 0.999 is between 0.99 and 1.0 because this is 0.990 and that's 1.00. So we know we're in here. And so this is 0.990. This is our 1.000. And here we actually have 0.999. Well, 0.9999 is still greater, so we're over on this section again. And so this is 0.9990. And to jump ahead, this is 0.99999. 4 nines, and this is 1.0000. So we're still in this bar over here, way over on this side, and we'll do it again. And so now we have 0.99949 nines and a 0, and here we got 1.00000. And right here we got 0.99999. And so we're in this bar once again. And so let me ask you this question. When we're on this bar, how close are we? So let's ask this question like this. So when we're in this bar, when we're in this range, what is most distance from 1.0 if the number is on that section of the number line? So follow me here. We only got a couple minutes, and I'm going to try and explain this. So if we're here, any number here, this is the furthest number. 0.990 on this bar here is the furthest number from 1.0, and it's only 0.01 away from 1.00, right? 0.99 is 0.10 away from 1.0. And you could have got that by saying, well, what's 1.00 minus 0.99? And you get 0.01. All right. Now let's say we know that the number's in there. Well, we also know that the number's in here. So now we're closer. We know that we're closer. We've shown using our strategy that we're at least this close. This number over here is 0.001. This one's only 1/1000th from 1. So we know this is the furthest number. This is as far away from 1 we can be if we're in this range. Well, up here we knew we were, 1/100th, which is 0.01. Here we're 1,000th. Similarly, here we're 1/10,000th, or 0.0001 away. We're getting closer to 1. And here we're 1/100,000th away, or 0.00001 away from 1. So each time we do this, each time we draw a new magnified number line, we get closer and closer to 1. And the biggest possible gap decreases. By 1/10 of what it was. So the idea is, can we keep going? If we keep going forever and ever and ever, we can keep drawing this picture forever and ever and ever and ever, forever. And if we keep going forever, our gap gets close to 0, because eventually, after we've done this 1,000 times, we're going to get a gap of 0.0000000000000000000000001. But then we can keep going further and further and further and further. And so ultimately, what you can show is that there is no gap. There is no gap between 0.9 forever and 1, because if you ever say that there's some gap here, I can just draw you another picture and show you that we keep going to the right, and 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 the right, till basically we're at 1. So that's the argument. I don't know. If you buy this argument, you can tell me that you buy the argument. If you don't buy the argument, you can say, I don't buy this argument. But in 8th grade and 9th grade, this is about as good an argument as we get. Actually, I'll take that back. In a few more lessons, we might even get a better argument that 0.9 forever is the same thing as 1. But we'll wait until later to show it to you. Hopefully this was an exciting and fun lesson. If nothing else, it'll get you through tonight's homework, and then we'll move on to bigger and better things as time goes forward and we approach the end of 8M7. Okay, well, hopefully you enjoyed the lesson. Tomorrow, 8M7, lesson 8, we're going to continue on with decimals and infinite decimals and converting decimals and fractions and decimals and infinite fractions, et cetera, et cetera, et cetera. Happy math, happy cat, happy life. I will be talking to you soon.